You're standing on a red plain beneath a salmon-colored sky. Dust clings to your boots. The wind is silent until suddenly you hear something impossible. A wave. You look up and see it. Water, rushing down an ancient Martian riverbed. Cold, fast, real. What if Mars had water again? It's not as far-fetched as it sounds. In fact, some scientists believe we're already on the brink of this becoming reality. And if it happens, this wouldn't just mean a wetter Mars. It could mean a second Earth, or a second extinction. Because bringing water back to Mars might unleash alien ecosystems, spark a planetary climate disaster, or even expose humans to something far more dangerous than we ever imagined. So buckle up, because if Mars had water again, our place in the universe might never be the same. Let's rewind the clock, about 4 billion years. Mars wasn't always a dry, dead desert. Once it flowed with water. There were rivers, lakes, maybe even oceans. The evidence is carved right into the landscape. Massive canyons, ancient shorelines, sediment layers, all pointing to a time when Mars may have looked more like Earth's arid regions than an alien wasteland. One region, Aeolus Dorsa, has preserved what look like braided river channels from hundreds of millions of years ago. Another, Gale Crater, was likely a lakebed for millions of years, possibly teeming with microbial life. But something changed. Mars lost its magnetic field. Without it, solar winds stripped away the atmosphere, temperatures plummeted, the air thinned, water either froze beneath the surface or vanished into space. And so Mars went from being possibly habitable to completely hostile. But here's the question. What if we could bring that water back? The Great Melt. To make Mars wet again, you'd first need to melt what's already there, and there's a lot more water than you think. Scientists have found vast reserves of ice beneath Mars's surface, some just a meter deep. Estimates suggest there's enough frozen water to cover the entire planet in a global ocean over 30 meters deep. And at the poles, things get even more extreme. The Martian polar ice caps contain millions of cubic kilometers of water and CO2 ice. If we were to melt all of it, we'd not only flood the lowlands, but also thicken the planet's atmosphere dramatically. Imagine the Hellas Basin, a massive impact crater the size of Mexico, filling with water to become the largest lake in the solar system. Or the Valles Marineris, so long it would stretch across the United States, transformed into a twisting, island-dotted river system larger than the Amazon. This isn't just science fiction, it's physics. Heat plus ice equals water. The challenge is where the heat comes from. Terraforming tactics. So how do we heat up an entire planet? Option 1, nuclear detonation. Some scientists, yes, including Elon Musk, have suggested dropping nuclear bombs on Mars's poles. The idea is to rapidly vaporize the ice caps, releasing greenhouse gases, which would trap heat and start a warming cycle. Option 2, solar mirrors. Gigantic orbiting mirrors could redirect sunlight onto specific regions of Mars, slowly increasing temperatures and melting permafrost. Option 3, industrial-scale greenhouse gas emissions. We could build giant Martian factories to pump CO2, methane, and other gases into the atmosphere, essentially warming Mars the same way we've accidentally warmed Earth. But here's the catch. Terraforming Mars wouldn't take years. It could take centuries, or even 1,000 years, and it would require more energy than humanity currently produces in a decade. Even then, there's no guarantee it would work. Mars lacks a magnetic field. Without one, solar radiation would continue stripping away the atmosphere. We'd be fighting a never-ending uphill battle. So maybe instead of trying to fix Mars, we could simply flood it. Triggering ancient lakes. What if we didn't need to terraform the whole planet? Instead, we could target specific regions. Use drilling to tap into subsurface aquifers. Melt glaciers with concentrated solar heat. Inject steam into caves and lava tubes to create localized wet zones. This kind of micro-terraforming might allow us to form temporary lakes, rivers, or even wetlands, turning select areas into habitable zones while leaving most of the planet untouched. These wet zones could serve as test beds for life. Engineered bacteria could be introduced to begin producing oxygen, Algae and mosses might follow, slowly building primitive ecosystems. And here's where things get interesting, really interesting. Life reawakens. What if Mars never truly lost all its life? In 2020, scientists found signs of liquid water beneath the South Pole. Deep, salty, and isolated, these lakes might still harbor microbial life, survivors from a time before the planet froze. Now imagine we warm the surface, and that heat reaches below. Suddenly, those microbes wake up after lying dormant for billions of years. Would they be harmless? Maybe, but maybe not. After all, these organisms evolved in total isolation. They might contain proteins, genes, or even biological processes totally unlike anything found on Earth. If they escaped, they could infect machines, interact unpredictably with Earth life, or even prove toxic to human colonists. The moment Mars gets wet again, life could find a way, but we might not like what it becomes. Colonists versus catastrophe. Let's say we succeed. Mars now has lakes, rivers, and weather patterns. Colonists live in high-tech habitats beside artificial shorelines. Drones buzz overhead. Crops grow in domed greenhouses. This is Earth 2.0, right? Not quite. Mars has only 38% of Earth's gravity. That means water would behave differently, flowing slower, evaporating faster, and carving shallower channels. Over time, human bones would weaken, muscles would atrophy. Children born on Mars might never be able to return to Earth due to structural differences in their bodies. And without a magnetic field, the thickened atmosphere wouldn't last forever. It would erode slowly, year by year. Every lake would need to be artificially replenished, every raindrop preserved. Mars wouldn't be self-sustaining. It would be a managed illusion, one power outage or atmospheric leak away from collapse. So yes, Mars might have water again, but would it ever be alive again? What if Earth lost its water? Here's a flip side to the question. What if Earth lost its water, like Mars once did? We'd face massive ecosystem collapse within months. Crops would fail. Wildlife would disappear. Within a few years, human civilization would collapse. In other words, water isn't just important, it is life. And that's exactly why Mars, with water, has such powerful potential and such terrifying risk. So, what if Mars had water again? We could watch deserts bloom. We could build the first alien cities. We might even discover ancient life, reborn. But we'd also face radiation, gravity loss, climate collapse, and biosecurity nightmares. Terraforming Mars could take generations and still never make it truly livable. And yet, we dream of doing it anyway. Because Mars isn't just a dead planet. It's a symbol, a challenge, a mirror. It shows us what Earth could become if we're not careful. And it reminds us just how rare and fragile our watery world really is. So whether or not we ever flood Mars again, let's make sure we don't dry out Earth in the process.